Okay, so FRQ 32, we are allowed a calculator. So on A, please answer A. Okay, so we are supposed to rewrite as a single logarithm. So if I take f of x, remember that addition is going to mean that we're going to multiply those together and then find the value of f of 7. So this I'm just now substituting and calculating. And then I need to be able to get that answer by going change a base. So log 14 divided by log 3. Go to 3 decimal places and I get 2.402. Okay. All right, on B. Okay, so here we were supposed to subtract. So you will see my work. I have g of x minus f of x. Pay attention, I put brackets because I'm subtracting the entire thing. So what I did here was I distributed my negative and then I condensed those into one log. You could have also have worked on this one and multiplied them and then subtracted. But either way, doesn't matter as long as you get to the bottom line here. And then we're going to evaluate, right? So we're going to plug in 1 and we're going to evaluate that and we get negative 2/4, which that means there's no solution because remember the argument cannot be negative. See? Okay, so where are they equal to each other? So I set them equal to each other. I'm going to condense them to be on one log on each side. Once these guys are the same base, I can just set these arguments equal to each other and solve. It's quadratic, so I've got now x is equal to 3 and negative 2. But remember, you always have to check. So I need to, I'll start by plugging in the 3. When I plug in the 3 into the x portion, it ends up giving me a negative 2 for the argument right here and a negative 6. So so x equals 3 is not a solution. If I go in and do negative 2, I also notice that plugging in the negative 2 for all of those x values end up giving me a negative argument as well. So in this case, there is no solution. Okay, 33. All right, so we have the relationship between the intensity I of light measured in lumens at a depth of x feet in Lake Erie is given by this equation. Same thing, but in Lake Superior is given in this equation. So answer A. Okay, so what is the intensity of the light in Lake Erie at a depth of 70 feet? So again, I'm just going to replace x with 70 and go ahead and solve for I. So remember the base of a log is 10, so 10 to this power is equal to I over 12. And then I just calculated this number, gave me this. And then I'm going to multiply both sides by 12 and then go to 3 decimal places. Okay, B. Okay, so we are working a little bit backwards here. It says at what depth, so we're solving for x, right, to the nearest foot, is the intensity of light in Lake Superior 2.8. So again, we're replacing I with 2.8 and we're solving for x. So again, we can calculate this. Actually, all we need to do if we're solving for x is to divide this number. So we've got log of 2.8 over 12 divided by negative 0.0125. So we need to put this in the calculator. And then that is going to be 50.562 feet. It says to the nearest foot. So we're going to go with 51 feet. Okay. See? Okay, so solve both intensity equations for I in terms of x by investigating graphically, so that means we're going to use Desmos, at what depth for x is greater than 0 is the intensity in both lakes the same. So the first thing we're going to do is solve for x, solve for I. And so we end up getting this equation. So type this into Desmos. Don't put I, you can put y. All right, and then the next thing we're going to do is do Lake Superior. Same thing. We are going to put this one into Desmos, and you can put this as y or leave it alone. You're going to look for those intersection points. Well, it turns out that the intersection occurs at 012. So the intensity of the light is never the same in either lake because look at this. It said x is greater than 0. Um, so it is exactly at this point, which is at 0, so we can't include that. So it's never going to be the same in either lake.